Hello, this is Professor Zara and the second video regarding cost behavior. Now, we had left last video, let's go right here, and I had used, this is how you predict costs, is you take the line, and the line, like I said in the last video, is the line is the answer. If I ask you what is the cost function, getting the using the high-low method with this data, following the last video, you would have done that. Now, when I left the last video, I was like questioning myself if I had done this right. But it seems to me like this example from the book was built. I went ahead and did regression. It looks like this example from the book was built to almost have a perfect line, which is not necessarily realistic. So we'll be doing more of these in chapter 3. We'll do another example of these. But anyway, so these you need to distinguish between your actual costs, and these were your actual costs here, and your predicted costs. Okay, that this is supposed to be a big title, but anyway, your predicted costs would be this. And notice that, and the reason why I was questioning this was because it seems like, except for this first one, the actual is equal to the predicted. I think that the example was built to be that way, so we'll just have to deal with it. Okay, so anyway, so that's the first way. Okay, the next way to build a cost function is to use a scatter graph. Okay, and it's going to be the same, almost the same for the scatter graph as the high-low function. But in the scatter graph, what we're going to do is make a graph and visually take out any outliers. We're going to look at the data, and then we're going to ask ourselves which one of these data is not representative of a linear pattern, and then we'll pull that value out, and then we'll do basically the high-low method without the outlier. Okay, so let's go ahead and see what we can do here. Let's go ahead and see if we can build a scatter graph. And I assume you know enough Excel level scatter graph is you put you highlight the data you want, then you say insert, and then go to recommended charts. I can tell you it's going to say scatter graph, and that looks good, and I'll tell you why it looks good in a second. But anyway, I'll go ahead, and there's our scatter graph right there. And just to doll this thing up, I'm going to go ahead and put add a couple of chart elements here. I'm going to add an axis title. Let's say the axis title here is units. We'll put it down here. I'll just write units there. Okay, and click over here to get that in, and then I'll just go ahead and add another element, and I'm going to add another axis title. I'm going to put vertical. I'm going to put total cost. Okay, and I'm going to put y here because in most regressions, y is the dependent variable, and it's the dependent variable here because the cost depends on the number of units. And I'm going to put x for the units here for the independent variable. These are just the way, and I'm doing that for when we get to regression here. Okay, so I'm going to put in the word, just the letter x, usually because in regression, generically, x is the independent variable and y is the dependent variable. Okay, so I'll just go over here and stretch this out. Anyway, so let's leave it like that. Okay, and so if you look at this graph here, the one point that seems to be sort of out of control is the very high point, 120,000 and 4,400 units. That one seems to be sort of the outlier. And so using the scatter graph method, that's what you're looking for. You're looking for outliers. Okay, and our line this time should be even better than the line last time because we're taking the outlier out. Okay, so what we're going to do is, since the scatter graph told us that that's the outlier, what we're going to do is take it out, and basically, using the book's methodology, we'll take out the outlier, and we will use the high-low method. We'll use the high-low method, but using the next point as the high point. And so what we'll do is we're going to take this out, and let's see if we can just cross this out. Any way to just cross this out? I don't think there is. But we're going to, instead of using, we're going to take this one out, and we're going to do the high-low method using point number 1 as the high point. So we'll use point number 1 as the high point, and then we'll keep point 6 as the low point, because the outlier wasn't, the outlier was right there. Okay, so basically we're going to do exactly what we did last time, but we'll use the high point and the low point. And so what we're going to do here, this should be fairly easy. Okay, so once you've got the outlier identified, you pull the outlier out, and that's the outlier right there that you see me pulling out of the graph. I've sort of taken it out. So I'm taking out the 4,400, month 3, 3,300, 120, and then what we'll do is I'm going to go ahead and copy this part over to see what we get here. Okay, so we'll copy this over. Hopefully we can do this. Okay, so let's see what we get here. Okay, and so I'll text it in first. I'll go ahead and put the text in first. Then we'll do our recalculation. Okay, so the high point is no longer going to be $120,700. The high point is now going to be $82,700. We're pulling out the outlier, so it's going to be $82,700. $82,700, and the high point will no longer be 4,400 units, but it's going to be 3,300 units. 3,000 units, excuse me. We're keeping the low point the same. Okay, so that's what we're going to do. So let's go ahead and recalculate our variable cost per unit. Our variable cost per unit is now going to be 82,700. Got to put parentheses there. Minus the low point of 43,100 divided by the new high point of 3,000 minus the low point, the old low point, the continuing low point of 1,200, and we get variable cost per unit of 22. And that, yes, that matches the answer. Okay, and now we're going to compute the total fixed costs. Okay, so the total fixed costs are now going to be 82,700 rather than the 127. So 82,700 is going to be that, and the low point stays the same. So this equation is going to be basically the same, and let's make sure to change our variable cost per unit. It's going to be $22 per unit. Okay, we'll go down here. We'll put $22 per unit again, because our new variable cost per unit is that. So our new total fixed costs are going to be 87,200 minus your variable cost per unit, your new variable cost per unit, which is 22, times the high units placed in there, and our new variable cost, that is the correct answer, 16,700. Okay, and our new variable cost can also be obtained using the low point, which is going to be 43,100 minus $22 times the low units. Should give us 16,700 also. Okay, so your new answer, your new answer is if I asked you if you were using a scatter graph and pulling out the one outlier, what would your new cost function be? Your new cost function would be 16,700 plus $22 times the number of units you produce. Okay, so that's your new function right there. Okay, and now let's go ahead and then you can try the predict thing again. Let's go down to, but let's go over to regression. Okay, and in regression is a statistical technique. Okay, and it really is. This is the one we're going to be using, by the way. So regression is a statistical technique, and it is one we're primarily going to be using. Okay, and so this is just an introduction to regression, and then we will we'll be doing more of it in the next chapter. Okay, but I want you to learn how to use functions. Okay, and keep in mind what we're trying to do here. We're trying to come up with a line that looks like total cost is equal to total fixed cost plus variable cost per unit times the number of units produced, sold, whatever. Okay, in this case. Okay. And we're trying to fill in two variables. Trying to fill in that variable right there, total fixed cost, and we're trying to fill in the VC unit right there. And once you have those two variables, you have the answer. Okay, now in regression, Excel does regression for you. Okay, and so what Excel does is it can build this line for you using different functions. Okay, so I'm going to start by estimating using Excel our total fixed costs, and I'll also estimate the variable cost per unit. Okay, now for total fixed costs, what you're going to use is you're going to use a function that is called the intercept. And the reason it's called the intercept is because if you look at, let's say, this line right here, you can imagine a line, and we could put a line in there very quickly. Let's see if we can put a line in here. Let's just do this. See if there is something we can do with this. No, we'll do that later. But you could actually put a line in here, which wouldn't be exactly on those dots, but you could put a line there, and it would cross somewhere around 20,000, a little over 20,000. It actually would cross, if you did a line right there, it would cross at 16,700. So imagine a line through a lot of these dots, okay, and it would cross, if you're looking at this thing, according to our calculations, it would cross at 16,700, which would be somewhere down here. And the reason, and that would be your level of fixed cost, which would go straight out. Now, it's called the intercept because that's where the line would intercept the vertical axis. So Excel has a function here. Okay, Excel does have a function, and I'm going to go ahead and just sort of spread these out again. Okay, and I'm going to go ahead and emphasize again, that's going to be your Y variable. That's going to be your X variable. That is the case. Okay, and so Excel does have a function, and so what you got to do is hit the equal sign. Hit the equal sign right there, and write in the word I, and start writing the word. You're looking for the intercept. Now it's gonna pop up this little box there, and just click on intercept. Okay, and notice what it says. It says intercept, and then you're gonna highlight the known Y's and the known X's. Okay, now we know that the known Y's, that's why I put Y, are right here. We're going to put a comma. And the known X's are put right here. And using regression, and read the book about regression, but what regression does it tries to fit a line which minimizes the difference between your observed points and your predicted points, because the line should not be perfect. No line is perfect. But let's see what we get here. So if you use regression, your total fixed costs are going to be 14,202. So your total fixed costs are 14,202. Okay, and so that's going to be your total fixed cost in the total fixed cost line. Okay, and then your variable costs. For your variable costs, what you're going to do is you're going to use a function called slope. And the reason we're using a function called slope is because it's the slope of the line, which is rise the rate at which it rises over the rate at which it goes off to the right. Okay, so it's rise over run, we always say. Okay, but basically it's the slope of the line. Okay, and I'll assume you know some basic algebra. Okay, so using the function here, we're going to go is equal to slope. Okay, and once again, I'll just go equals slope, and we'll click on that. Slope. Okay, so it comes out, and just go ahead and click on where it says slope. Notice that once again it says insert known y's, known x's. We know our known y's are these data right here. Put a comma in there, and our known x's are those right there. And our slope is going to be $23.92. The variable cost per unit is going to be $23.92, whatever. Okay, 93 cents. Okay, and so the total cost line using this, using regression is going to be, if I asked you what is your total cost line, your answer for me would be your total cost line. I'll just put it up here. Is 14, total fixed costs are 14,202 plus your variable cost per unit is, let's just say $23.93, $23.93, and I'm just going to put times units produced. Okay, so that would be your answer right there, and I'm going to emphasize that your total costs would be equal to that number right there. To your total cost function would be that. That would be in red right there, which you ought to give me. Total costs are equal to, get this in here, total costs are equal to 14,202 fixed costs plus $23.93 times the number of units you produced. Now to finish this video off, I'm going to go ahead and show you a couple things here. Let's go ahead and copy these data down like I did last time. I'm still wondering about those numbers, but I think I'm looking at the example, the solution, and it does look like this example is built to fit almost perfectly. Okay, so our actual, we had 7 months. 7 months. Our actual sales data were these numbers right here. Our actual total costs were these right here. So using our function here, let's go ahead and do our predicted cost. Okay, and the predicted cost is going to be based on the line total costs. Total cost is equal to 14,202 fixed cost plus $23.93 per unit times the number of units produced. Still wondering about I'm almost positive they threw this example together to fit perfectly. Okay, so let's put this in. Okay, so our first number is, we got 87,200. Okay, and so was our actual. So what we're going to do is, we know that our total fixed costs are 14,202. We're going to have some rounding error, plus $23.92 times the number of units produced, which was 3,000 in this case. So our predicted cost here would be $85,998. Now let's go ahead and freeze both the total fixed cost that we're using in the equation and the total and the variable cost per unit that we're using in the equation. Okay, and let's see what we get going down. Okay, and those look pretty good. Notice that those are very close to the numbers. Okay, they're not as perfect as in the first set of data I used for high-low, but I think this example was built to give you a perfect line using the high-low method. It goes to near perfect line, but these are close. Okay, and two more things, and I'll finish here, just so you can get used to regression. So what we're saying is that, and you'll be using regression because most real-life cases the high-low method doesn't even work, but you know, because you don't build examples to that. Okay, so first thing we're going to do is we're going to compute what are called residuals, and stop there. So I'm going to put residuals here. And residuals are just the difference between your predicted value and your actual value. So your predicted value here was 85,998, and just subtract out 87,200. So residual there was 32,988. We go down here, and on a percentage basis, this is your largest residual. The other ones are fairly immaterial. So this looks like a good line. This looks like this line should be a good fit here. Okay, and I'm going to compute one more thing here. Okay, and then there's also a statistic you'll read about in the book called R squared. And in loose terms, what R squared gives you is R squared tells you the percentage of variation in the dependent variable that is explained by changes in the independent variable. So in this case, your R squared would tell you how much of the variation in total processing costs is predicted by changes in sales orders, because there could be other variables too. Total processing costs, maybe the salaries of your salespeople, their incentives, and all that stuff. Okay, so you'll notice that in Excel, there is another. We'll do R square. There it is, R square, and R square. We'll just click on here. We're going to do known y's and known x's again. Okay, so R squared will give you the prediction based on this equation line. You get that. So known y's are these numbers. Known x's are these numbers. And this is why this example and why we got such perfect numbers using the high-low method. This equation, and notice these residuals are small. And you got $179 residual out of $43,000. That's small. These are all very small residuals. This one even is $1,200, but it's also based on $120,000. It's basically less than 1%. This is the one which may be a little off. That's the one that seems to be off both here, by the way, and in the high-low example. But this is saying 99% of that your sales orders account for or explain total. The changes to sales orders, variation sales orders, explain 99% of your total processing costs. So this example was built. Actually, I was right the first time. This example was built to be almost perfect. We'll be doing this for examples that aren't perfect. But what I'm going to want you to do for homework, and I'll tell you this in email, is I'm going to send you a sheet. I'm going to send you a worksheet. I'm going to send you this worksheet, and I'm going to send it to you with the explanation. I'm going to send it to you with the high-low method. I'm going to send it to you with the scatter graph. And what I'm going to ask you to do is recreate what I've done here for regression, because regression really is what you have to know. And so I'll stop right there, and we'll be doing more regressions in the next chapter. and just one more regression, and we'll actually put a scatter graph in there. So I think next chapter I'm gonna put the scatter graph in here for regression line, but you can try to graph it yourself. What you would try to do is graph those three things right there, but I think this is enough for you. Anyway, so what you're going to have to do for homework, besides my business course exercises, I'll send you this worksheet, and you will have this, the high, low, and scatter graph, and you'll have to build a regression line using functions. Okay, and the reason I'm using functions is because you've got to do that because Excel does have an analysis tools pack, but a lot of the Excel versions that are used publicly don't have this, and it's nice to know the functions anyway. Anyway, so I'm going to stop there, and I'll post this video. Thank you very much. Bye.